Good day, viewers. I welcome you to today's class. We are still on the series of the solution of system of linear equations. In our last video, we looked at the Gaussian elimination method. Today, we shall be looking at the simple elimination method, S.E.M. The simple elimination method, S.E.M. We shall be considering a 3x3 system of linear equations. This is the problem we have been solving at the introduction of the topic solution of system of linear equations. We use the matrix inversion method to solve this particular problem. We got x1 to be equal to 1, x2 to be equal to 2, and x3 to be equal to 3. We also use the Gaussian elimination method to solve the same problem in our last video, and we got the same result. It means that this particular system is consistent and is unique. A system of linear equation is said to be unique, is said to be consistent, is said to be independent if it has only one set of solution. If it has only one set of solution. If it has more than one set of solution, it is inconsistent and dependent. Once again, my name is Dr. Chris Esekaibe. I am the owner of this YouTube channel, Dr. Chris Esekaibe. The essence of the channel is to share knowledge across the globe, to teach key topics in mathematics and statistics and share it across the globe. Why not? It is a privilege to teach mathematics and statistics, or topics in mathematics and statistics. It is as a result of my wealth of experience I've gathered over the years. I am a chief lecturer in one of the most prestigious polytechnics in Nigeria. I work in Nigeria and I live in Nigeria. I hold a doctorate degree in mathematics with distinction. I hold a master's degree in mathematics and a bachelor's degree in statistics. I am a specialist in numerical analysis, data analysis and modeling, statistical analysis, and scientific computing. If you are a research firm, you do a lot of research, statistical research, why not? I can be part of your researchers. You can contact me. If you are also an AI firm, you deal on artificial intelligence, I can be part of your team of mathematicians and statisticians creating models, mathematical or statistical models or algorithms for artificial intelligence. My contacts are +234 80 330 21903. This first contact is for call and for WhatsApp. The second number is +234 7066 297535. My email is chrisdavid2015@gmail.com. I'll be looking forward to hearing from you. I hold I have scholarly publications within and outside Nigeria, and I also have presented papers in renowned conferences within Nigeria and outside Nigeria. I've authored quite a number of books in statistics and numerical analysis and in applied statistics also. So permit me to go to the business of the day. Let me clean this off. I'll be looking forward to hearing from you. Just contact me. I'm just a call away. Then with your research, just like the way somebody contacted me from Rwanda, an MSc student in mathematics who specializes in numerical analysis, I was able to play one role or the other. Just a word of advice is enough as a result of my wealth of experience. So today we shall be looking at the simple elimination method for solving system of linear equations. We shall be looking at this particular system. This system, we have used two different methods to solve this system. The solution to any system of linear equation is very important in every field of study. Is it in sciences, in engineering, in architecture, in medicine, whatever field, you hardly come across a field where you not see a system of linear equations to be resolved. So we are looking at the direct methods of solution. We looked at the matrix inversion method, we looked at the Gaussian elimination method. Today we are looking at the simple elimination method. This is one of the simplest methods for solving any system of linear equation. In next video, we shall be coming up with the simple substitution method. We have the Cramer's rule, we have the Cholesky's algorithm. There are so many methods. We'll be taking these methods one after the other. So now, if you are to use the simple elimination method known as the S.E.M, simple elimination method to solve a given system of linear equations. Now, this system is a 3 by 3 system. It has 3 equations and it has 3 unknowns to be resolved: x1, x2, and x3. Now, using this simple elimination method, the first thing you do is to pick a variable or one of the 3 unknowns that you want to eliminate. And you are going to combine them. For instance, if you eliminate x1 from equations 1 and 2, you are going to get a simple equation having x2 and x3. Then again, since you have picked x1 and you have picked the first equation and the second equation, then you can now pick whether any of either the first and third equation or the second and third equation to still eliminate x1. So now the first step is eliminate x1 from 1 and 2, from equations 1 and 2. So write it out. Why am I eliminating x1? Because x1 here in equation 1 has coefficient of 3, x1 in equation 2 has coefficient of 3. So I'm going to write them out. 3x1 plus 3x2 plus 5x3 is equal to 24. Then we have 3x1 plus 5x2 plus 9x3 is equal to 40. Now I'll rule a line. You can see that x1 and x1 here in this equation and this equation, they have 3. Their coefficient is 3, they are the same. If the coefficients are not the same, I will multiply this first equation by the coefficient of x1 here and multiply this second equation by the coefficient of x1 here, so as to make the coefficient of x1 the same, so that it will be easier or easy for me to carry out the first stage of elimination. So now, since they have the same coefficient, I can go ahead and subtract. 3x1 minus 3x1 is 0. 3x2 minus 5x2 is minus 2x2. Then 5x3 minus 9x3, that will be minus 4x3. Then you put your equation sign. 24 minus 40 will be minus 16. So since both sides of the equation is having the negative sign, you can now come and have it as minus into 2x2 plus 4x3 is equal to minus 16. So this minus will cancel out. So you now have 2x2 plus 4x3 is equal to 16. So you call this one equation 4. So this will now be your equation 4. Is that clear? So this will be equation 4. You now come again and see how you can eliminate x1 again from either equations 1 and 3 or equations 2 and 3. We combine equations 1 and 2. This is equation 1, this is equation 2, this is equation 3. So we combine equation 1 and 2 to get equation 4. Now we can combine equations 1 and 3 or equations 2 and 3. So let us take equations 2 and 3. So from equation 2 and 3, eliminate x1. So we can now come here. What we are going to do, we have 3x1 plus 5x2 plus 9x3 is equal to 40. Then we have 5x1 plus 9x2 plus 17x3 is equal to 74. Now you can see that x1 in equations 2 and 3 are having different coefficients. They are having different coefficients. So what we need to do, we come here, we multiply this one by 5, which is the coefficient of x1 in this second equation. Then we multiply this one by 3, so that x1 in the two equations can have the same coefficient. So this implies that when you carry out that multiplication, you are coming here 5 times 3, it will be 15x1 plus 5 times 5 plus 25x2 plus 5 times 9, 45 plus 45x3 is equal to 5 times 40 will be 200. Then the next one, 3 times 5, it will be 15x1 plus 3 times 9, 27 plus 27x2 plus 3 times 17 is 51 plus 51x3 is equal to 3 times 74 will be 222. Now you can see that the coefficient of x1 in the two equations is 15. So you can now go ahead and subtract. Then you rule your line. 15x1 minus 15x1 is 0. 25x2 minus 27x2 is minus 2x2. 45x3 minus 51x3 is minus 6x3. 200 minus 222 is minus 22. So you have that. Then permit me to come up a little. You are going to have minus into 2x2 plus 6x3 is equal to minus 22. Minus will cancel out. So you are now going to have 2x2 plus 6x3 is equal to 22. Call this equation 5. So you can see how we have been able to carry this out effectively. Now we have produced, we eliminated x1 from equations 1 and 2, we got equation 4. We eliminated x1 from equations 2 and 3, we got equation 5. Now, from equations 4 and 5, permit me to clear this part of the board, we want to now eliminate x2 so that we can get x3. We want to now eliminate x2 so that we can get x3. We want to eliminate x2 so that we can get x3. So you come now, you say from 4 and 5, comma, eliminate x2. So you come here, what is our equation 4? Our equation 4 is 2x2 plus 4x3 is equal to 16. Then equation 5 is 2x2 plus 6x3 is equal to 22. Now you can see that both of them have the same coefficient. You can go ahead and eliminate x2. If you don't have the same coefficient, you multiply the second one by the coefficient of x2 here, then you multiply this one by the coefficient of x2 here. But since they have that, you go ahead. So you now have 2x2 minus 2x2 is 0. 4x3 minus 6x3, that will be minus 2x3 is equal to 16 minus 22, that will be equal to minus 6. Call this one equation 6. So from equation 6, from 6, we have x3 will be equal to minus 6 all over minus 2, and that is equal to 3. So this implies that x3 3 is equal to 3. So you can see how we have used, from the first two equations we eliminated, from equations 1 and 2 we eliminated x1. From equations 2 and 3 we eliminated x1. We now produced equations 4 and 5. Now from equations 4 and 5 we have eliminated x2 to have x3 left. So we have been able to get x3 successfully to be 3, permitting to claim this part of the board. So now that we have done this, we have gotten to this level, it will be very easy to get our x2. So from any of equations 4 and 5, you can now say from equation, maybe you can even use equation 5. Okay, let's use equation 4. From equation 4, we have 2x2 plus 4x3. 4x3, our x3 is 3. 4x3 is equal to 16. So our 2x2 will be equal to 16 minus 4 times 3 is 12. When it crosses to the other side, it becomes minus 12, and that will be equal to 4. So x2 will be equal to 4 over 2, and that is equal to 2. You can see how simple that is. Now remember, for us to now get the value for x1, we have to use any of equations 1, 2, and 3. Because equation 1 has x1, x2, x3 in it. Equation 2 has x1, x2, x3 in it. Equation 3 also has x1, x2, x3 in it. Equation 4 only has x2 and x3. Equation 5 has only x2 and x3. It is equation 6 that has only x3. That's why we were able to make x3 the subject of the formula in equation 6. So we reduced and reduced and reduced using the elimination method till we got to equation 6, where we have only one variable left, and we now made that variable the subject of the formula. Now from equation 1, we have 3x1 plus 3x2 plus 5x3 is equal to 24. So now let's put these values in. 3x1 will be equal to, okay, let's continue, plus 3 into our x2 is 2, plus 5 into our x3 is 3, and that is equal to 24. So here you are going to have 3x1 plus 6, 3 times 2 is 6, plus 5 times 3 is 15, is equal to 24. So 3x1 is equal to 24 minus 6 minus 15, and that will be equal to 3. So this now implies that x1 will be 3 all over 3, and that is equal to 1. So it simply means that by conclusion, our x1 is equal to 1, our x2 is equal to 2, and our x3 is equal to 3. That is the end of the solution. So you can see that we have now arrived at the same answer with the Gaussian elimination method. But this simple elimination method looks easier, looks simpler, and looks faster. It is faster, it is simpler, and it is very, very easy. It is easier than the Gaussian elimination method. You can see how we have been able to achieve this. So beloved, you can see how we have been able to use the simple elimination method to resolve this same problem, and we arrive at the same answer. X1 is equal to 1, x2 is equal to 2, and x3 is equal to 3, making this system of linear equation to be unique. A system of linear equation is said to be unique and consistent if it has only one set of solutions. We have used 3 different methods of solution to solve the same problem, and we end up arriving at the same answer. x1 is equal to 1, x2 is equal to 2, x3 is equal to 3. It makes the system independent, it makes the system consistent, and it also makes the system unique. So beloved, I will be coming up in our next video with the simple substitution method. The simple substitution method, we are going to use it to solve this same problem, and we'll see if we arrive at the same answer: x1 equals 1, x2 equals 2, and x3 equals 3. So watch out for the simple substitution method as we use it to solve the system of linear equation. Please subscribe to my YouTube channel, Dr. Chris Esekaibe. As you do, God will bless you. Share my videos in your social media platform. Click on the like button, click on the notification button, so that you will be able to get a notification each time I upload a new video. I will be looking forward to hearing from you. If you are an AI firm, a research firm, so that I can have the privilege to partner with you and share my wealth of experience with your team of mathematicians and statisticians. God bless you. Enjoy the rest of the day. Bye.